Hey class, this is lesson 64. The topic is semicircles. A semicircle is this shape right here. It's just half of a circle. Semi means half. I'm going to review a little bit about the circle, which we learned about a few lessons ago. Much of the information is going to be a review. We're going to use some of the information that we learned in our lesson on circles and apply it to the semicircle in order to look for the perimeter and the area of a semicircle. Okay, so reviewing some of the terminology from our lesson on circles, look over here at my circle. The line that goes from one edge to the other edge of a circle and passes through the center is called a diameter. Okay, a line that goes from, or I should say the distance from the center of the circle out to any edge is called the radius, right here. And I told you that some mathematician in ancient of days discovered that if you wrapped a diameter around the outer edge, it would wrap around pi number of times. And if you recall, the value of pi is 3.14. Pi is a Greek letter, and they use that to stand for the number of times the diameter wraps around the outside of the circle. Once that mathematician found out that pretty important information, once we understood that value pi, now we can calculate the perimeter of the circle, that is the distance around the outside the circle, all the way around, and that's called circumference. We don't call it perimeter when we refer to circles, it's called circumference. And so as I told you in that lesson, the value for the circumference of any circle is pi, the number of times the diameter wraps around, times the diameter. So that's the value of the circumference for any circle. That's right here. Look down a little lower. I told you that the area for the circle is that value pi times the radius squared. They don't actually give us how they found that out. That's probably for a higher level math, maybe college or beyond. Okay, so those are the values for the circumference of a circle and the area of a circle. So as you can imagine, if we want to find the, let me back up. Let me give you one more definition that's arc here. I was going to talk about the perimeter of a half circle, but in this lesson, we're more interested in finding not the actual whole distance around, okay? We simply want to be able to calculate this portion, just the arched part there. It's called an arc. So, definition. Any portion of a circumference of a circle is called an arc. And so that outer edge, this is getting sloppy, I'm going to erase this again. Any portion of the outer edge of a circle is called an arc, and so we refer to this part of a semicircle, excluding the straight part, as an arc. Okay, it wouldn't be a true perimeter. That would not be going all the way around the shape, so that's an arc. So the information that we learned for the circle gives us the ability to find the length of that arc around a semicircle. And that's going to be, let's look over here again at my formulas, the distance of an arc of a semicircle is pi d, you'll recognize that to be the formula for the circumference of a circle, divided in half. Okay, that's pretty intuitive and obvious. So the distance around the arc of a semicircle is half of the circumference of the whole circle. And likewise, look at the bottom formula there. The area for a semicircle is going to be the same pi r squared as the area for the full circle divided by 2. So that's just half. So the whole principle here is that now we know how to find the value of the distance of the arc of a semicircle using the same formulas for a circle, and we can also find the area of that semicircle using the formula for a circle and dividing each of those in half. What are we going to do with that information? Okay, that's next. We'll erase all of this stuff. Actually, I think I have to clear my canvas to get rid of those. So let me clear everything here. There they are. Okay. What are they going to do in this lesson? What is your job going to be? All right, I'm going to draw a shape. Okay. So that is not a very good arc. But what you're looking at here is a square, and it's got two semicircles attached to it. And the problem set is going to ask you, what is the perimeter of the shape? And it's going to ask you the area of the shape. And you have to break this into sections to evaluate that problem. It's going to be section 1, section 2, and section 3. The other information they're going to give you is the radius of these semicircles. Sorry about that. So you'll get maybe, you might get this distance. You will get the radius of each semicircle. We'll say this is 6. This is not to scale. Okay, not to scale at all. 6 and 4. And then you will have to calculate the perimeter. Well, do I have enough information? Let's think about this. If I have a semicircle and its radius is 6, that means that this distance is 6 and this distance is 6, because that radius, right, it's from the center of that straight part of the arc of the semicircle out to any edge. That's going to be 6. So now I can say that this is 6 and this is 6. Now I have the length of that entire side. It's 5 plus 6 plus 6, and that's 17. Likewise, for the other semicircle, if my radius is 4, any of these are 4, and that means that this is also 4 and this is 4. So now I have the entire length of that side. I'm sorry. Yes, I have the entire length of that side, which is going to be this corresponding side over here. That's why that's important. All right, so I have two sides. Now my total side down here is going to be 17. Like I told you, this is not to scale. This is terrible, actually. And this is 8, but just focus on the numbers I'm giving you. So let's see if we can calculate the perimeter around the outside. I'm going to start with this side here, add in this side, and this portion here. So I have 17 plus 8 plus 5, and then I get to my first semicircle, and then I'm going to have to add in my second semicircle, the arc portion here, this, and that will give me my total perimeter. How do I calculate the arc? Well, as I told you before, it's pi d over 2. What diameter, you might ask? There's a radius shown there, not a diameter. Well, if you imagined this to be a full circle, the diameter would be this radius of 6, you would just double that. Okay, so you're imagining that arc, that semicircle, to be a full circle, and then you're going to calculate that circumference and divide it by 2. So this is going to be, for my area number 2, pi times my radius was 6, so it's going to be 12 divided by 2. And that's going to come out to be 12 divided by 2 is 6. That's going to be 6 pi. And I'll put that right there. I do the same thing for my next semicircle. All right. I imagine this to be a full circle. I look at my radius of that semicircle is 4. If I extend that to a diameter, right, that's going to be 8. So for my area number 3, it's pi times the diameter divided by 2, and that's pi times 8 over 2. I can divide 8 by 2, and I get, I'm going to flip pi to the other side there. That's kind of standard standard notation. So I am okay if you leave this in terms of pi. You can add up the constants, 17, 8, and 5. What is that? That's 30. And I'm going to say if you have 6 pi and 4 pi, you have 10 pi. I'm actually okay if you leave it like that. If you want to put in 3.14, Multiply it by 10, you would have 30 plus, what would that be? 31.4. If pi is 3.14, and that would be 61.4. That's okay too. But I'm totally fine if you leave the answer in terms of pi. Right? That was a little bit messier than I hoped. Okay. I'm going to draw one more. If you got it and you got it down pat, you totally get what's going on, I am cool. If you just go ahead and do the problem set, I'm going to work another one really quickly if that was a little fuzzy. All right, and hopefully draw better pictures. All right, there's my two semicircles. Let's do this again. This is 7, and if this radius here is 0.5, and this radius is 4, and I need the perimeter. Okay, if this radius is 4, then I know this distance is 4 and this distance is 4. If this radius is 5, I know this distance is 5 and this distance is 5. Adding across the top my 4 plus 4 plus 7, that gives me 15 and tells me the length of my bottom edge there. If I have 5 there and 5 there, I know that this distance is 10. Now I have all the distances around the edge. I just need to calculate my distance around my two arcs. So it's going to be, I'm going to start with 10 and go around in clockwise fashion. It would be 10 plus the arc, which I'm going to calculate, plus 7 plus my second arc, plus 15. My first arc is going to be, its radius is 4. If I double that to a diameter, it's 8. So it's going to be, I'm going to come over here, pi d equals pi times 8 divided by 2. My second arc is going to be pi d, which is pi times 10 divided by 2. You simply need to divide the numeric portions, 8 divided by 2, and that leaves you with 4 pi. My next one, 10 divided by 2 is 5. That leaves me with 5 pi. So I can add in 4 pi and 5 pi. I'm going to combine my constants, 10, 7, and 15. That's 17 and 15, that is 32, plus 9 pi. That's how you would calculate the perimeter of these shapes. All right, the other thing they ask is the area. So let's do an area. You're going to have to do perimeter and area. How do we calculate the area? All right, we have 3 sections. We have 1, 2, 3 sections. I'm going to start with 1. That's side times side, 10 times 15. And that's 150. My second area is a semicircle over there. And the area for a semicircle is pi r squared divided by 2. And that's pi, our radius is 4 squared divided by 2. Likewise, for area 3, it's pi times the radius, which is 5 squared divided by 2. So this is going to be pi times 16 over 2, and that 16 divided by 2 is 8. I like to write it like that. Whoops, pen just stopped. There we go. Oh, I'm sorry, my pen stopped writing. Don't know what's going on. Sorry, class. Where did my whiteboard go? Oh my gosh, hang tight. There we go. Sorry about that. Okay, where was I? I think we're back in business. All right, so area 2 is still a little big. There we go. It's back now. Okay, 8 pi. Our area 3 is pi. 5 times 5 is 25 over 2, and that's 12.5 pi. All right, so let's add those areas. 150 plus 8 pi. There's definitely something glitchy going on. Plus 12.5 pi, and that is 150 plus 20.5 pi units squared. All right, we'll just call it feet squared. Sorry, that was a little bit quirky. So that is how we're going to discover both the perimeter of a shape like this and its area. All right. Sorry, that was my drawings were poor, but hopefully you got the hang of that. Okay, it's just the formulas for the circles divided by 2 to find that arc and find that area. All right, signing off.